All right, let's talk about one of the coolest ideas in AI right now. We're going to explore how you can take a general-purpose model, one that knows a little bit about everything, and transform it into a world-class specialist in the one thing you really care about.
So you've probably played around with these incredible large language models. I mean, they can write poems, they can summarize articles, they can even write code. They are seriously smart. But here's the question we need to ask. Are they actual experts?
And that difference? It's everything. A generalist AI, the kind trained on the whole internet, is basically a jack of all trades. But a specialist AI, that's a master of one. It's gone through some very specific training to get deep expertise in a single area, whether that's legal contracts or medical diagnostics. And that is when these AIs go from being a cool toy to an absolute game changer.
So how do we make one of these specialists? Well, it all comes down to a powerful technique called fine-tuning.
You know, the best way to think about it is like this. A big pre-trained model is like a brilliant university graduate. It's got a massive amount of general knowledge. Fine-tuning is like sending that graduate to medical school. You take all that existing knowledge and then train them again, but this time on a very specific, high-quality data set, like medical textbooks, to turn them into a specialist, a doctor.
And this chart, well, it lays out the difference perfectly. That initial pre-training, that's the heavy lift. It builds the general knowledge base using just tons of data over weeks or even months. But fine-tuning, that's the specialization phase. It's way faster, it's cheaper, and it uses a much smaller, really focused dataset to get the model ready for a specific job, like being great at summarization.
Now, it's worth pointing out that fine-tuning isn't your only tool in the toolbox. If you just need your AI to access new information, say your company's internal documents, a technique called RAG, or Retrieval Augmented Generation, is probably what you want. But if you need to fundamentally change the model's behavior, its personality, or its core understanding of a subject, that's when you bring in fine-tuning. Okay, so you've decided fine-tuning is the way to go. What does that process actually look like? Well, it's not just a single switch you flip. It's a whole pipeline, a journey that takes you from raw data all the way to a fully deployed expert AI.
Let's walk through this journey together. It all kicks off with stage 1, data prep, where you're getting all your specialized data ready. Then you move into initializing the model and setting up your training environment. Stage 4, right in the middle there, that's the main event, the fine-tuning itself. But you're not done. After that, you've got to rigorously evaluate the model, then deploy it so people can actually use it, and finally monitor it to make sure it keeps performing as expected.
Now, I know 7 stages might sound like a lot, but you can really boil this whole pipeline down to 3 core phases. First, you prepare everything: the data, the model, the whole setup. Second, you actually tune the model. And third, you deploy and maintain it out in the real world. Simple as that. Okay, now this is where things get really clever. See, for a long time, fine-tuning was just ridiculously expensive. But a new set of techniques came along that completely changed the game, making the whole thing radically more efficient. So here was the problem. A big language model has billions, literally billions of parameters. You can think of them as all the little knobs and dials that control how it behaves. Traditional fine-tuning meant you had to tweak every single one of them. And as you can imagine, that takes a staggering amount of computer power, time, and money. This simple question led to a huge breakthrough. What if, instead of trying to rebuild the entire engine, you could just add a small, high-performance chip to get the job done? And here's the solution. It's a technique called LoRa, or low-rank adaptation, and it's just genius. What it does is it freezes the billions of original parameters, locking in all that core knowledge. Then it injects these tiny new trainable layers right into the model. So instead of updating the entire massive thing, you're only training these small, super efficient adapters. It's like a surgical approach to teaching an old AI new tricks. And the results? They are absolutely staggering. An even more advanced version called QLoRa can cut the memory you need for fine-tuning by up to 18 times. This is such a big deal. It means you can now fine-tune massive models on a single GPU, something that was just a dream a few years ago.
So, let's step back. What does all of this really mean for the future? Why is turning these generalist AIs into focused specialists so important?
Let's recap the 3 big takeaways. First, fine-tuning is the key to turning generalist AIs into powerful experts. Second, it's not magic, it's a structured process that follows a clear pipeline. And third, and this is maybe the most important part, techniques like LoRa are making this power accessible to everyone.
basically democratizing the creation of expert-level AI.
And that democratization of AI leads us to one last really exciting question. We are moving from an era where only a few giant tech companies could build powerful AI to one where pretty much anyone can create their own specialized expert. So, what new frontiers are we going to cross, and what incredible problems will you solve next?